Continuing on, we've started discrete probability distribution. So the example question here we've got is a magazine store recorded the number of magazines purchased by customers in 1 week. 23% purchased 1 magazine, 28% purchased 2, 21% purchased 3, 13% purchased 4, and 5% purchased 5. Let X be the number of magazines sold to a randomly selected customer. So state the possible values of X. So X is the number of magazines sold. So realistically, X could equal, in this one here, we've got X. If you look at this, the question doesn't give you the chance that no one bought a magazine. So we're looking at this here, and that's a bit, not really. We're looking at X equals 1, because we can buy 1 magazine, then we've got 2, 3, 4, and 5. So 1, 2, 3, 4, 5. These are all in the question here. So if we're looking at this, 1 represents that one there. We're looking at the next one here, 2. Okay, this is dead simple, this stuff here. So 3 is that one there. Where are we going? 4. Okay, so all my values are stated in the question. I haven't just assumed that we're going up. All right, construct a probability table for this scenario. So sweet. How good is this? We're going to go here, and I might clean this up a little bit later, but the probability of X equals our X value, and we're just going to use X at the top here. So we've got 1, 2, 3, 4, 5. Okay, so that was given from above. We've figured out that that's the amount of magazines sold. All right, getting close now. So now we've got we can sell 1, 2, 3, 4, 5 magazines, but we need the probabilities of this. So the probability of 1 magazine was 23%. So we start representing these as decimals, 0.23. 2 magazines was 38%. 3 magazines was 21%, so 0.21. And then 4 magazines was 13%, 0.13. And then 5 was 5%, so 0.05. All right, graph the probability distribution for these. So mine's not going to be, unless I go over a little bit. So let's graph these. So I've just come over, so I've got more room here. So we put X on the bottom. We're going to be looking at 1 was our first option. Then we had 2, 3, 4, and 5. And you notice I'm putting a big gap here between them. Okay, and so I've just gone up here. Let's count this as 10%. So 0.1 here, 0.2, 0.3. Okay, which will mean 0.4 is here. So our first one, 0.23, will be sort of about here. Okay, so this won't, obviously, if you have a ruler, you could do this pretty much very close. The probability of 2 was 38, which is almost here. Okay. Now, the probability of 3 was 0.21, so just above that. Okay, that's obviously going to be a pain. So, okay, probability of 4 was 0.13, so that'll be about, well, that's no good. Yep. And probability of 5 was 0.5%, so got that there. Sweet, that's the graph done, all labelled. I need to label this axis probability. Cool. And then final bit here, find the mode and the median of this distribution. So straight off the bat from the graph, I've got this one here is going to be the mode. Okay, so the mode is X equals 2, or selling or we state our answer here. So sorry, the mode is when it equals 2. Most customers buy 2 magazines. All right, and then our next section here is the median. So the median, all right, in this section we've got, so the probability of the first, these are in ascending order, is 0.23. So our first step here is the probability 1 is 0.23, so not the median. The probability of 1 and probability of 2 is 0.23 plus 0.38, which equals 0.61, which is a tick. Now, this is important. We didn't pass 0.5 on the first one. We passed it on the second one. So therefore, our second value, 2, is what gets us past there. Therefore, customers buying 2 magazines is the median, or just 2 is the median. All right, cool. We've got that all sorted. All right, now I've just tried to cram the next example in the same one. So show that we've got this probability function here. So it's saying that if we put in these x values 1, 2, 3, and 4, so there's only 4 possible values of x, we want to show that it is a probability, it is a valid probability density function. So I'm just going to show you this in terms of a function. So we've got 1, 2, 3, 4. And so our probability of x here is going to be 1. So this will be 1 squared plus 1 over 34. Okay. Now, I'm just going to actually answer these. I'm going to talk you through them. So 1 squared is 1 plus 1. So we've got 2 over 34 here. And then our next one here is 2 squared, which is 4 plus 1. So we've got 5 over 34. Our next one here is 3. 3 squared is 9 plus 1 is 10 over 34. And our last one here is going to be 4 squared is 16 plus 1 is 17 over 34. Now, this is, the reason I've quickly crammed this in is because this is actually a good one. The 4 outcomes here, we need to state for a valid PDF for probability density function, the probabilities all need to be between 0 and 1. And this is a tick. So I'm going to write this as a sentence for us so we can actually state it. So all probabilities, just going to have to move that over. All probabilities lie on the interval. So they lie in this interval. That's the most important thing. These are all between 0 and 1. They're all bigger than 0. Oh, it doesn't matter if they equal 0. So they all are 1. Now we just need the other one, which is the sum of pi from I equals 1 to n. N in this case is 4. Equals 2 on 34 plus 5 on 34 plus 10 on 34 plus 17 on 34, okay, which equals 2 plus 5 is 7 plus 10 is 17. 17 on 34 plus 17 on 34 equals 34 on 34, which equals 1. So this is a big tick. Both these things are correct here. So we've stated both these. So therefore, this is a valid probability density function. Okay, I've rushed through that a little bit to try and keep it quick for you. So just double check the notation there, but we've got the probabilities all for this particular example lie on that.